Hello everybody and welcome. Today's presentation is Preventive Security for Kubernetes Enterprise Deployments, brought to you by Aqua. Now I'd like to introduce you to our presenter. Liz Rice leads Aqua's technology evangelism activities in the cloud-native ecosystem. She is an active member of the open source community and an award-winning speaker known for her live coding demos. She is currently co-chair of KubeCon and Cloud Native Con. Prior to getting immersed in containers, she built up a wealth of software development, team, and product management experience working on network protocols and distributed systems, and in digital technology sectors such as VOD, music, and VoIP, with companies including Skype, Last.fm, and Metaswitch networks. Well, without further ado, I'm going to turn things over to Liz to begin the presentation. Liz?
Fantastic, thank you very much, and welcome everyone to today's webinar on preventative security for Kubernetes. What we're going to cover today, we will, oh, my slide didn't work very well there we go. We're going to talk about how we can configure Kubernetes for security. At a high level, we'll talk about how configuration can affect security. And then we're going to talk about two specific approaches you can take for improving your security by addressing that configuration. One of those is by applying the CIS benchmarks. I'll talk about what those are. And we'll also talk about how you can use penetration testing and a tool that we've been working on to help you with Kubernetes specific penetration testing to help you identify whether your deployment has any significant vulnerabilities. Before we get started, I'll just mention a book that I've just recently co-authored along with Michael Hausenblas from Red Hat. It's about Kubernetes security, and the good news is that we are giving out copies of this ebook during this webinar. It's one of the handouts that you'll be receiving as an attendee for this webinar. Before we get started into the rest of the content, we do have a couple of polls. So if we could start those polls now, that would be great. Okay, so the first one there is asking about the status of your Kubernetes implementation. I guess we give you a few moments to answer that.
Yeah, 74% so far, so we'll give a few more seconds for any final answers and we'll close that out.
Okay, and the second, first one, the results. Okay, so just over half of you are still thinking about your Kubernetes deployment. You haven't deployed yet, but you're planning one. And then there's a pretty even split amongst people who are in kind of a testing phase or have deployed a few apps into production. And then there's actually 14% of you who have deployed many apps in production. So there's a significant number of attendees who, are really using Kubernetes today for serious. So I hope the tools we'll talk about today won't unearth anything too scary in terms of vulnerabilities in those deployments. Okay, let's move on to the second poll question. So this is really asking you whether you're using the open source Kubernetes as kind of downloaded from the Kubernetes distribution, or are you using either a commercially supported hosted Kubernetes option, or perhaps the Kubernetes that's supplied by one of the cloud providers. So again, we'll give that a few moments for you all to give us your answers.
We have 69% so far, so we'll give a few more seconds before we close that out.
Okay, so around half of you, the largest number of respondents, are using the Kubernetes supplied by one of the big cloud vendors like GKE or AWS's Kubernetes or Azure Kubernetes. We also have a quarter of you using the straightforward open source Kubernetes, what we described in the question as vanilla open source, and a good 15% of you using OpenShift. Great, that's very helpful and good to know. With that, let's move back to the slides. Okay, before we get into the open source tools that I want to talk about, we'll just cover a little bit about Aqua. So Aqua Security provides a container security platform that really helps you protect your container-based deployment through its whole life cycle. So we really believe in automation, helping you manage your security through automation. And you do that by securing the CI/CD pipeline and trying to push the security approaches as far as possible left along that CI/CD pipeline so that you can fix issues before they get anywhere near deployment. Automation is really going to help you speed up deployment in the same way that DevOps introduces automation to speed up the development process itself. Containers offer us a very useful unit of abstraction for security, and they have a lot of characteristics that we can take advantage of. For example, enforcing the immutability of container images. And Aqua is a portable platform, if you like. We work on all of the different distributions of Kubernetes. We also support non-Kubernetes container deployments. If there are any of you out there not using Kubernetes, we do support security or securing on platforms like Docker Swarm, Mesos Marathon, and other container orchestration systems. So we very much believe in securing your containers wherever you're planning to run them. Now, today I'm really going to focus on a couple of tools that you can apply during that CI/CD pipeline. In particular, looking at how we're going to protect the hosts that we are running our Kubernetes workloads on. So let's take a look at a very simple representation of that CI/CD pipeline. Super simple. We write software, we build it into software artifacts, and we deploy those software artifacts into the cloud. And at each stage, there are several things we can do to improve security. When we create software and build software, there are things we can do like static analysis and code review to ensure that as far as possible, we don't build any security issues into the code that we write. And we can automate testing of security issues as part of the testing that we do in our CI/CD pipeline. When we build containers, we not only pull in our own code, but we also pull in third-party libraries. So typically we're going to be building on a base image. We might be installing a number of different dependencies, different packages into the image. And we need to introduce vulnerability scanning to make sure that those dependencies that we've imported into our image don't contain known vulnerabilities. So by the time we've built some software artifacts, we really want to know that as far as possible, they are free of security defects. And then at the deployment stage, we have two main elements of securing our deployment. One is to ensure that the hosts are configured in a secure manner, and the other is to ensure image policies, to make sure that the code that we're deploying is what we expected and that it's configured in the way that we expected. And then finally, when we're running software in the cloud, we want to make sure that it's behaving as expected, and we could use runtime protection tools such as Aqua's to detect when something unexpected is happening, because that may indicate some kind of breach, some kind of compromise. So at every stage along the CI/CD pipeline, there are things we can do to improve the security of our deployment. But today I am particularly going to focus on the aspect of host configuration, making sure that we're configuring the hosts and the Kubernetes software in particular to be as secure as possible. So Kubernetes host configuration. There are several different Kubernetes components. There are several master components like the API server, the controller, the proxy, and then every node also has a component called kubelet running on it. And all of those components have some settings that will affect security. That could be things like whether or not you have to authenticate to the APIs in that component in order to operate them. It could be things like whether or not you're running with RBAC turned on, role-based access control. So how you're going to run authentication and authorization within Kubernetes. And it could also include things like configuring the etcd data store to be encrypted. Every one of these components has configuration settings that affect security. A great example is that if you, well, every kubelet running on every node has an API, and if you can control, if you can get into that API, it is as if you had root access across that node. And if you can get into one kubelet, you can basically get into all of them. So an open kubelet port is the equivalent of root access, and that's not something you want to give away. So you need to make sure that the configuration settings don't open things up to this kind of insecure access. Now, the defaults that you get will depend on the installer that you're using. So whether you're using KubeADM or KOPS or perhaps some installation tools that you've built yourself. And unfortunately, in the early days, the defaults tended to be insecure. It's often been the case that to make things easy to stand up, to make it easy to get a Kubernetes cluster up and running, developers have chosen to use insecure settings by default. Now, that has been improving a lot in recent releases. I would say probably since 1.8, the defaults have got increasingly more secure. And for example, if you use KubeADM to install your cluster, you will no longer by default leave your kubelet port open. But if you're running maybe an older configuration, or perhaps depending on the installation tools you're running, you may not have confidence that your configuration is secure. And how do you even know what a secure configuration looks like? How do you know which of all these different settings you should be worried about? And how do you know what values those settings should take? That's a very long question to answer, and it's answered by this document called the CIS Kubernetes Benchmark. The CIS is the Center for Internet Security. It publishes a number of these different benchmarks that essentially tell you how what the best practices are for configuring different pieces of software from a security perspective. The Kubernetes benchmark just released version 1.3, which covers Kubernetes 1.11, and it is around 250 pages of best practices. It's something like 200 different recommendations. So it's a hugely in-depth document, and it's very useful. you may find that in your particular environment, not every single recommendation is right for you. For example, I had a conversation recently with one of the product managers from GKE who was explaining to me that some of the networking settings don't make so much sense in the context of GKE's own networking infrastructure. But running these CIS tests is a good starting point to at least identify things that you should be looking at, and you should be sort of asking yourself, well, if we didn't pass this recommendation, is that for a good reason? Now, of course, if it's 200 odd tests, that's going to be hard to run manually. So at Aqua, we wrote an open source tool called Kube-Bench, and this automates all of the tests in the CIS benchmark. There are tests available for both regular nodes and masters, and you can run this code. Essentially, we distribute a container, or you can take the source code directly from GitHub. And when you run Kube-Bench, you run it on each node, and you'll get results that look something like this, with a pass or a fail for the different tests. So there are some, there are a lot of these tests. And as you can see from this screenshot, it's really advising you that you should have certain settings, certain configuration settings set in a particular way. Many of them are as simple as saying, have you got this setting set to true? Or have you got this setting set to false? Have you got this setting set to 0? And Kube-Bench will check all of these recommendations and let you know when you're passing or failing. And it also gives you some remediation information that can tell you how to correct any of these tests if they're failing. The tests themselves are actually defined in a YAML file. So while the tests that we distribute are exactly what's defined in the CIS benchmark, if you wanted to, for any reason, modify them, perhaps because you have established that some of the recommendations aren't right for your particular environment, then you can easily do that by taking your own version of the YAML files. And we also have a YAML file that runs Kube-Bench as a job in your Kubernetes cluster. So it's easy to run on a regular basis. You need to run it on all of your nodes. So doing this as a sort of regularly automated job is a very good idea to make sure that the configuration doesn't somehow drift away from what's expected. If you are an Aqua customer using the Aqua Container Security Platform, the Kube-Bench tests are actually built into the product, so you can get an up-to-date view of how compliant you are with those benchmarks. And we also run the Docker CIS benchmarks as part of the Aqua tools. So Kube-Bench and the CIS benchmark will give you a very good indication of whether or not you are configuring, or whether your cluster is configured according to best practices. But then the question is, do you know whether that's really, how effective that is? And one way to find out is with penetration testing. So for those of you who don't know, penetration testing is the idea that you simulate an attack. There are companies that you can hire who will do penetration testing. They will attempt to hack into your system and let you know what they found. For Kubernetes in particular, we have an open source tool called CubeHunter. And this is doing penetration tests specifically for Kubernetes. The idea is that you can run these tests and get an indication of what an attacker would see if they attempted to break into your Kubernetes cluster. So the KeepHunter code, it's written in Python, it's available on GitHub. And we also have a website where you can get a nice kind of friendly, easy to read report on the results. So the idea is that this is going to tell you how well the configuration that you have set up is actually working to secure your cluster. Have you got the configuration set up in such a way that maybe people can access your kubelet ports? KubeHunter will tell you if that's the case. So if we go to the KubeHunter page, you'll see something like this, which gives you the command that you would need to run. You can, well, you run this and you'll see something like this where you get to choose whether you want to specify the address of a cluster to attack, or perhaps you want to test locally. You can specify a subnet or an IP range. And KubeHunter will go out and make attempts to contact different Kubernetes ports and explore what's available. It will try to find the kubelet API ports, the API server ports, the etcd ports, and so on. And it will report back to you with what it found. So what we're seeing on the screen at the moment is the terminal version. When the tests are all complete, you can load a pretty report onto the website that would look something like this. I actually ran this earlier today on a v1.9 cluster, Kubernetes cluster, which I had configured to have some issues. So, for example, we can see some, well, high severity remote code execution vulnerabilities that are possible on that cluster I had running earlier today. And we can also see things like information disclosure. That first, in the middle of the screen, we can see a medium severity disclosure that tells us that Kubernetes version that's running was 1.9. And while it may not be directly a problem if someone outside your organization knows what version of Kubernetes you're running, that could be helpful to an attacker to know what kind of exploits might be available in your cluster. So depending on your risk profile, you might be concerned about exposing that kind of information. Again, the next item down tells us how many pods are running. That may not be a concern. It's not telling us what the pods are, but you may not want to let people know that information. So KubeHunter is giving us this attacker's eye view of the cluster. And actually, one other thing I'll mention is that you can run KubeHunter inside a pod. So there's a YAML file that makes it easy to run within your cluster, and that will simulate it will simulate a compromised pod. If you were running software in a pod that had an exploitable vulnerability, for example, suppose you were running code with the struts vulnerability that brought down Equifax or leaked a lot of information from Equifax, that vulnerability can allow an attacker to execute code within your pod, and running KubeHunter within a pod gives you an idea of the kind of attacks they would then be able to make from within that pod. Again, this is another area where Kubernetes has been improving the security defaults, but as an example, by default, the service account token is mounted into each and every pod, and that allows code executing inside a pod to have access to the API server. That's not a great idea. So KubeHunter is a really powerful tool for showing you what an attacker sees when an attacker looks at your Kubernetes cluster. Now let's think about how KubeHunter and KeepBench give us a sort of pincer movement on the things that we need to change in our Kubernetes clusters in order to remove the vulnerabilities that they find. So for example, in that report that I just showed you on the cluster that I was running earlier today, one of the examples was finding that anonymous authentication was enabled on the kubelet. In other words, the KubeHunter was able to issue a network request as an anonymous user, a user that essentially doesn't need to provide credentials. So anyone could access that kubelet and make requests to the kubelet's API. So KubeHunter was able to do that. But if we look at the output from Kube-Bench, we can also see, this was Kube-Bench run on the same cluster earlier today, and we can see that one of the tests that's part of the CIS benchmark is, well, it failed, and it said anonymous authentication argument should be set to false. In other words, anonymous authentication should not be enabled. This was not true on this cluster, so it failed that test. And if we look at the remediation information that Kube-Bench gives you, it tells you how to correct that problem, how to make sure that anonymous authentication is turned off in your system. So that's an example of finding a problem with KubeHunter and then using Kube-Bench to figure out how to correct that problem. The same is true for a lot of the configuration issues that you can find in the CIS benchmark. So that really concludes what I was going to say about the preventative tools that we offer at Aqua as open source tools that can help you configure your Kubernetes cluster more securely. If you are going to be attending KubeCon in Seattle in December, and I hope a lot of you will be, then please do come along to the KubeSec Enterprise Summit. It's a co-located event the day before KubeCon starts, and we will be looking into other aspects of enterprise security for Kubernetes all day. We're going to have speakers from lots of different companies. It's an event that is sponsored by not just Aqua Security, but also AWS and Red Hat, and it's going to be a very exciting day. So do register for that on the Kubernetes or the KubeCon website. So with that, I am ready and able to take any questions that may have come into your mind while I was speaking about Kube-Bench and KubeHunter. Thank you very much.
Great. We have a few questions here. Audience, if you have any additional questions, please go ahead and post those into the questions panel now. First question that we have: how do you prevent an insecure image from being instantiated in Kubernetes?
Right, so the first question is, how do you even know that an image is insecure? So if I think back to the CI/CD pipeline, I mentioned the idea of vulnerability scanning. And for some definition of an insecure image, we hope to identify that with vulnerability scanning. So for example, if you're using the Aqua platform, we'll scan each image, look for known vulnerabilities, and flag that up. Then the question is, how do you prevent that image from being deployed? And that's where image policies come in. And if, again, casting our minds back to the CI/CD pipeline, at the point where we're deploying software, we want to be able to check and make sure that the images don't have problems, that they meet our policies, where those policies might include don't deploy anything with high severity vulnerabilities, or maybe don't deploy anything with medium or high severities, depending on your particular security requirements. So image policies are the way we, or that's the abstract thing that we need. In practice, you can do that using admission controllers in Kubernetes, and you can do it with Aqua's commercial tool as well. So the admission controllers you would probably have to pretty much write for yourself. or you can use this, we provide that as part of our enterprise solution. Okay, next question.
We have, can I scan running containers for vulnerabilities?
You could, but it wouldn't be a great idea. So the thing is, once you have a container that's running, it's been instantiated from a container image, and you probably have more, you may only have one instance of a running container, but you've probably got several instances of that container, and they're all based on the same image. It really makes sense to scan the image that it came from, not the running container itself. Now, there are other things you might want to do in the running container. For example, in Aqua, we have runtime profiles. So we learn what the behavior of a container, what normal behavior looks like in terms of what executables it runs, what user IDs it runs as, what kind of network traffic it will accept or produce. And flagging up when something outside of that profile, something that's unexpected happens, is a really, really powerful thing. So that's what we call runtime protection. But that's not the same thing as scanning. And if you're scanning the actual containers, that would probably be a waste of resources, because you're probably scanning multiple instances of the same thing. Far better to scan the image that it came from and treat those images as immutable. I hope that answered that question. Okay.
Great. Kubernetes already has a secrets solution. Do I need Aqua's? Okay,
so we a little bit away from the KeepBench and KubeHunter with that, but yeah, so secrets, when we talk about secrets, we're talking about things like credentials that need to somehow get into a container. The system needs to somehow ensure that the right container gets the right secret at the right time. And Kubernetes Secrets offers us a way to do that. The only problem with Kubernetes Secrets is that they are by default stored in etcd, and etcd, you will need to make some configuration changes to ensure that your etcd is encrypted. That's one of the things I am 99% confident there is a test in the CIS benchmark to cover the encryption of etcd. And so many enterprises will choose, rather than storing their credentials in etcd, to use a dedicated secret store. Something like HashiCorp Vault, CyberArk, the KMS systems that are available inside of Azure or AWS. They're all great places for keeping secrets securely. And then it really just becomes a question of injecting those secrets into the right containers at the right time. There are plugins available that can support at least some of those mechanisms using Kubernetes Secrets, but Aqua also provides a very powerful solution that plugs in between these different key management stores and your containers and injects them directly at runtime without the need for configuring Kubernetes Secrets. So that's a very easy to use and very powerful way of managing getting those credentials into your running containers.
Okay. I have two different questions here that seem fairly related, so I'm gonna ask them kind of together. What is the frequency new vulnerability tests are added, and how frequent does KubeHunter update the vulnerabilities list?
Okay, so KubeHunter itself doesn't look for vulnerabilities. We do have another tool actually called Microscanner, which does the vulnerability scanner for vulnerabilities. Well, actually, it depends what you're talking about. If you're talking about vulnerabilities in container images, then we would need Microscanner. And Microscanner is actually a free to use version of our commercial image scanner, and that's updated. Well, we have a whole research team that are constantly updating that as new information is found. It connects to the National Vulnerability Database, which gives us kind of enumeration of all the possible CVEs. But then we also need to keep up to date with patches that different distributions have made and patches that vendors have made. And there's also quite often room for interpretation to make sure that we don't have false positives. So we keep that up to date really as an ongoing process. And that's to do with image scanning. So scanning the code that's inside your container images. Now, if we come to KubeHunter, so I couldn't tell you that KubeHunter is a comprehensive set of all the possible ways that somebody could attack a Kubernetes cluster. And in fact, we're working on, I know there are some pull requests right now for new tests that we're adding to the product. And this is like an arms race, right? There are attackers out there who will be coming up with new and creative ways to attack Kubernetes clusters. And we would love to have a comprehensive set of tests to inside KubeHunter to mirror that, if you like. There's a lot of catching up to do. We've basically got tests for the kind of basic things that are really obvious that could be misconfigured. We're starting to add some slightly more interesting or unusual cases. We've got lots of ideas for some, more creative potential attacks that we can test for, but there is no end to this journey, right? There will always be more attacks that people could come up with, and we welcome pull requests. So please do, particularly for KubeHunter, if you have ideas that you want to suggest or even code, we very much welcome that input.
Great. How will core DNS be beneficial over Cube DNS?
Oh, that's a good question. I am not a DNS expert, and I haven't done the comparison myself, but my understanding is that it's more performant and will be better at scale. That's pretty much everything that I know about that at this point.
Okay. Beyond Kube-Bench, KubeHunter, what would you consider the next most important tool to use for Kubernetes/Docker systems?
I would say image scanning. If we think about actual real attacks that happen, the things that hit the headlines, the Equifaxes and the Teslas and all these data breaches that cost enterprises millions of dollars in reparations and cost consumers endless heartache. They nearly always come, the root cause is that somebody is running software with a exploit that's not a vulnerability that's known. So for example, in the Equifax case, there were 2 months between the vulnerability being published and the breach happening. So that was 2 months in which they could have updated their software. And whether you're running containers or not, this really applies. You really need to keep on top of security. In traditional deployments, we called it security patching. With containers, we have this amazing, well, not just containers, with containers and CI/CD pipelines and the concomitant automation that we're building in. It should be pretty easy to build in image scanning. So for example, Microscanner, if you're an Aqua customer, it's built in as part of the whole container security platform. If you're not an Aqua customer, use an image scanner. I'm going to tell you that Microscanner is the best scanner, and to my to the best of my knowledge, it's going to give you the least false positives. But to be honest, I would advise you to run any vulnerability scanner, because if you can identify whether you're running with high severity vulnerabilities, that is probably the single best defense against likely known exploits, aside from things like leaving your API server open. So yeah, KeepBench and or KubeHunter to look at your configuration, and image scanning to make sure you're not running vulnerable application code.
Okay, we got a couple more questions right now. Is there any way to configure Kubernetes so that predefined NFS exports on an external NFS server are only available for the pods that belong to a particular namespace, and other pods and other namespaces cannot mount it?
Okay. So I think this is really coming down to what bind mounts you are permitted to access from a particular, from a container within a given namespace. I do know off the top of my head that you can limit the mounts that are permitted inside containers with Aqua's platform. Now I'm trying to think if there is anything. I think there are. I'm trying to think if there's something in pod security policies that allows you to limit what external mounts you can pull in. I don't think they would be. I don't think it would be on the basis of this is an NFS mount or not. I think it would be more on the basis of here is the path to the mount point. I would have to double check. I would say the most likely, if there is something in Kubernetes, would be in pod security policies. You can definitely do it inside the Aqua platform.
Great. We have one more question right now. These are really great tools. How is the Kubernetes community using the results to enhance the security of their own solutions, whether it be cloud or on-premises clusters?
Oh, that's a really good question. So I do know from discussions with, essentially, I'm actually one of the authors on the CIS spec, and I know that the cloud providers are kind of increasingly paying attention to that and looking at how they can make sure they're compliant. I think part of that is customer driven. They have customers who are coming to them and saying, how can, I want to make sure my deployment is compliant with CIS, and therefore I would like the cloud platform to kind of do that for me. So I think we're definitely seeing the big cloud providers, it's important to them that their customers can run securely. So they've definitely been positive and kind of involved in that. And we've also seen some really nice feedback from people, contributions to both KeepBench and KubeHunter coming from the community, where people have had ideas or improvements, particularly for KubeBench. A lot of the things that I mentioned about making it easy to run, like the YAML job, that came from an external contributor who basically thought, I would like to make this easier to run. So it's been fantastic to see these things. And I love the fact that we're contributing some tools into the community, and it seems like people are finding them useful. So that's really very, very rewarding.
Okay, well, that's all the questions that we have right now. Do you have anything else as we wrap up?
I would love to say, well, thank you very much to everybody who asked questions. There were some really good ones in there. I hope you found the webinar helpful. If you do have feedback on any of our tools, we'd love to hear it. GitHub is the best place to raise those ideas or feedback, or you can reach out to me on Twitter. I'm Liz Rice on Twitter. And I will just finally mention again the KubeSec Enterprise Summit, and I hope to meet some of you in person there.
Great. Well, thank you very much, Liz, for a wonderful presentation today. I'd also like to thank today's sponsor, Aqua, for providing the DZone audience with a great webinar. And lastly, thank you to everyone who joined us today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.